Section 7.5, algebraically defined vectors and the dot product. So the first thing we're going to talk about now is the position vectors. Now, a position vector is of the form u equals sum ab. And if you think about how this is set up, when I draw my xy plane, the idea of this is, I'm going to draw this in a different color here, is that let's say this is my vector right here. Okay, so what the A would be, this would be my A axis and B axis. That's kind of the idea here. So my A would be here. And my B would be up there. Okay, so that's the idea how this works, and then that creates this vector. Now remember, and don't forget, a vector is a line segment. It doesn't continue. It starts down here and ends up here. So just kind of keep that in mind as we go through this. A vector is not a ray. It has a beginning and an end. An initial point, which is down here, and an end point, which is up here. And they call this the initial, they call this the terminal point. They also call this the tail, and they call this the head. And remember, when we're talking about position vectors, they always start at the origin. So anytime I see this form here, this bracket here, A, comma, B, with another pointy bracket there, that's telling me right away I'm dealing with a position vector. And that position vector is starting at the origin. That's going to be its initial point always. So now let's say we had vector V, and vector V was equal to -3, comma, -2. Okay, so then that tells me I would go over 3 this way, -1, -2, -3, and then I would actually go down 2, which would put me here, and this would be my vector. So that would be vector V. Okay, that's how I draw my vectors. So I kind of treat these like ordered pairs in a way. So -3 in the x, -3 in the y. But instead of this being x and y, this is really my A and my B. Now, another thing we can talk about besides just graphing these vectors is actually the magnitude. How can I actually find this length of this vector here? So think about it this way. If I drew right triangle here, okay, I know this here is -3, and I know this is -2, or I can just call it 2 and 3, couldn't I? Because I'm just trying to find the magnitude here. So I can just think of that as 3 and 2, and I could use the Pythagorean Theorem for this since this is a right triangle. I can just take 3 squared plus 2 squared, and then that's going to be 9 plus 4, and that's going to be, and this is going to be c squared, of course, it's my hypotenuse. Okay, so this is going to be c squared here, so that's going to be 913 equals c squared. So then my c is actually going to equal square root of 13. Now keep in mind here, when I square root both sides, I really have a plus minus. But since I'm talking about the hypotenuse of a triangle, I'm going to take the positive one of it. So c is going to be square root of 13. So the magnitude is square root of 13. And the way I would represent that is this way. I would simply say all right, now think about what I'm doing here in this whole process. And I can simplify this a little easier than what it is right now. So now let's think of this in the general sense. So in essence, what I have, if I was trying to find a magnitude, I would say, okay, here's my C. I would create this right triangle, and I would say, okay, this would be my distance A. This here would be my distance B. So then I would say A squared plus B squared equals C squared. Okay, and then I would say, okay, what would I do to solve for C? I would square root both sides. So then I would get A squared plus B squared. So this is, in essence, my formula. So I can simply say my u equals square root of a squared plus b squared. And I wouldn't just say u here. Let me get this right. I would say the magnitude of u. Okay, so this here is my formula for finding magnitude in general. All right, so let's take the vector v equaling 8 squared root of 2 comma negative 8 squared root of 2. We want to just find the magnitude here. So if it says find the magnitude, I'm just going to write this out. And I'm going to say, okay, that's equal to the square root of 8 square root of 2 squared plus negative 8 square root of 2 squared. And don't forget all of that square rooted. So then 8 squared, that's going to be 64 times 2. So that's going to be 128. Plus, because keep in mind here, a negative times a negative is positive. So therefore, that's going to be a positive there. Okay. And then the square root of 2 squared is just going to give me 2. So that again is going to be 64 times 2, which is 128 square rooted. So then this magnitude of v is actually equal to square root of 256. And that's my v there. So then I know the magnitude of v actually equals 16. So this tells me here, using this example here of v equaling the 8 squared root of 2, negative 8 squared root of 2, that the magnitude is 16. This is actually where vectors become a lot easier when I start thinking about these algebraically. And just keep in mind here when I'm dealing with this u equals a comma b, that's simply starting at the origin. Don't forget that. And this ab is where my head of this vector is. So something to think about there as we draw these. And finding magnitude is simple. I'm just going back to algebra now, which makes it kind of nice.